Shoot, I feel like I should take a snapshot of that. Ooh, that looks so pretty. Man. Okay, enough of that good stuff. So I'm going to go back to paper by 53, and I just want to pull that snapshot in real quick so we can have that for our records. Cool beans? So our experiment tonight will involve us dropping a basketball from a building. We're not going to do it as on a video, and we're going to track that basketball down. Okay. So let's see what else I can bring to light. I want to get into fields more, but I'll do that a little bit later because we're going to have to talk about electric fields and magnetic fields and stuff like that. So we're going to use some of these same principles to talk about those. Okay. Let's go ahead and go to video physics. And once we go to video physics, we are going to bring a new video in, but we're going to bring it in a different way. We're going to go to this plus sign here. So I'm going to select on the plus sign, and then I'm going to go to sample videos. So I'm going to choose the ball drop. And let's just go ahead and name this. Gravitation. I think I spelled that right. And I put my initials on there because I'm sure that I use gravitation somewhere else. So if we just watch the video real quick, you'll see someone dropping a basketball. Okay, looks pretty good. Let's set our origin and scale. And that means we need to go all the way back. So let's set our origin right here at the basketball. Okay. And we're going to scale this video with this meter stick. Okay. So it's 1 meter. Okay. That'll do. We're going to take a snapshot of that, of course. And I just want to let this play a little bit till it gets maybe to about right there. Go back to maybe halfway. Because I don't want I want the acceleration to be constant. Okay, I don't want the acceleration to have to speed up. If you guys can visualize that, you know how we have, well, we can get deep into that, but so let's go ahead and go to points. What I'm going to do this time, so I'm just going to surround this ball. I'm going to see, I have the ability to focus in on an object using this slider on the right hand side, on the left hand side. So let's focus in on the ball. There's a feature down here called track. Let's just track that ball. And let's see what happens. Look at it. It's just tracking it for us. And I want you to pay attention. I'm going to stop this before it hits the ground because we don't want it to bounce. We're not looking at that. That's going to give us some other data. So let's just stop it right there. And that is the end of us getting data. Can you believe it? Let's go ahead and share this video with points to our folder. And so now we analytically, well, I want to say we analytically, but we analytically found 9.81. We know what people have told us, and now we're going to verify all of that. So of course, we're not in Bernoulli's. We need to go down here to this one, and then gravitation is number 19. I shouldn't have anything in there, so I'm going to choose that folder and save. And I want to go ahead and bring the photo up. It's very important. Rename. So I want to say origin and scale. All right, so we have all of that. Now we need to take our data over. This is where our data is going to look. Probably don't even really need to look at it, but we want to look at the y velocity versus time. So we're going to analyze this data set here. Say done. I'm just going to share that data file, of course, with graphical, and then that's it. We're not even going to Microsoft Excel this time.